Hello everyone. In this session of CCNA series, I'll discuss different wireless LAN topologies in which access points are operated in non-infrastructure mode. Devices such as repeater, workgroup bridge, outdoor bridge, and mesh network made up of access points can be operated in non-infrastructure mode to build such topologies. Let's have a brief overview of each devices and topology, starting with repeater. As you know, wireless networks are powered by access points, which propagate wireless signals in a limited area, known as cell. Some users sometimes reach out of access point limits and lose the wireless signal. To extend our wireless network, we use additional access points to extend our network, like ESS. In some scenarios, it is not possible to run a wired connection to a new AP due to some or other reasons. In that case, you can add an additional access point that is configured in repeater mode. A wireless repeater takes the signal it receives and repeats or retransmits it in a new cell area around the repeater. The idea is to move the repeater out away from AP so that it is still within the range of both the AP and the distant client. By using a repeater, we can extend our BSS for the users that are remotely isolated, where the AP normal coverage is unavailable. Wireless repeaters are used to cater these remote users and are implemented at access point boundaries. A wireless repeater is a network device for propagating wireless network signals beyond the typical boundary of a network. Another type of device we have is workgroup bridge. Let's suppose you have a device that does not have a wireless capability and is capable of only offering wired Ethernet link. This is where the workgroup bridge comes into the picture. A workgroup bridge is a wireless device that provides wireless connectivity for wired infrastructure devices that do not have radio cards. The radio card inside the workgroup bridge associates with an access point and joins the basic service set as a client station. For example, some network printers or medical devices might be designed with only a wired connection. You can use a workgroup bridge to connect the device's wired network adapter to a wireless network. Here, WGB connects as a client of a BSS, or you can say that WGB acts as an external wireless network adapter for a device that has none. The laptop over there acts as a regular wireless client, while this network printer is associated with an access point to a WGB. There are two types of workgroup bridges. Universal Workgroup Bridge, or UWGB. WGBs that provide connectivity for only one wired device are referred to as Universal WGB. It allows only a single wired device to be bridged to a wireless network. Another type of WGB we have is Workgroup Bridge, a Cisco proprietary implementation that allows multiple wired devices to be bridged to a wireless network. The need for a workgroup bridge has greatly diminished because more modern devices are already equipped with wireless adapters to connect with a wireless network. Another type of WAN topology we can have is by using outdoor bridge. Sometimes you might need to have a point-to-point connectivity between two different LANs, separated by longer distances to a wireless network. An AP can be configured to act as a bridge to form a single point-to-point wireless link between LANs. Here, an access point can be used in bridge mode with special purpose antennas. Special purpose antennas are normally used with the bridges to focus the signals in one direction towards the antenna of other LAN. These type of connectivity can be achieved by using wireless outdoor bridge. Let's take a scenario where you might have a multiple remote branch offices and LANs. at multiple sites need to be bridged together. A point to multipoint bridge link allows a central site to be bridged to the several other sites. The central site will have a bridge that is connected to an omnidirectional antenna and will transmit the signal equally in both the directions so that it can reach the other side simultaneously. The bridges on the other side will be connected to a directional antenna aimed at the central site. Next, we have another type of topology known as mesh network. To provide wireless coverage over a very large area, it is not always practical to run Ethernet cabling to every access point that would be needed. Connecting all the access points with the Ethernet cable, I don't think so is a good practical approach. You can overcome this by connecting multiple access points in a mesh topology. In a mesh topology, wireless traffic is bridged from one access point to another access point in a daisy chain fashion using different wireless channels. Mesh access points can leverage dual radios and both radio channels using different range of frequencies. Each mesh access point contains a BSS on one channel with which wireless clients can associate. Client traffic is then usually bridged from access point to another access point over other channels. At the edge of the mesh network, the traffic is bridged to a wired LAN infrastructure. That's it for this session. I hope this was informative for you. Thank you for